The carbon capturing world came forward maybe 3 years ago more strongly. US joined, to the effort and tried to create a lot of incentives on that end to start to mature the technology. The first pioneer of mineralization, kind of point source mineralization, was in Texas in 2006, Skyonic, today called Carbon Free, that managed to scale to around 75,000 tons of CO2 that was treated and create sodium carbonates from this emission.
This is GreenUp, and today we are talking to Marat Maayan, founder and CEO at Airovation.
There is several challenges, and this is why you can't see it so common yet. First of all, the technology that's now starting to move forward, like ours, are still in quite early stage. Okay, we are moving from in-house pilot towards field pilot, but still it's not fully commercial sites that are stable and you just plug it in and it's working. Think about industrial heavy machinery. You need to plan a plant. Okay, it's a real site. It's a big site. It's sometimes quite huge capex. It's need a space. Sometimes they don't have any space for that. Okay, so it is a big challenge, and we have to be patient on that and not try to be, saying, "Hey, why nobody is doing nothing?" So it's moving forward. In the US, there's a lot of tax incentives that now pushing this industry forward. But carbon capturing will not going to be kind of dealt with a silver bullet approach. There's no one technology that fit all.
Can you tell us what are the current solutions to capture the carbon at source?
The technologies today, in some sense, split to two different types. Okay, one that are aiming to point source with the approach of utilization. Okay, so we're taking carbon and we create something from the carbon. It can be creating the fuel, it can be creating, in our case, minerals and some other commercial materials like sulfuric acid. But the idea is, for us, it's carbon to value. And there is a dynamics and the sensitivities of market that you have to analyze when you're going to value. Because prices of commodities are changing, price of minerals are changing. So it's not such an easy task. And on the other hand, you have carbon capturing, let's say, and removal or carbon removal technologies, like direct carbon capturing. Most of them are not fit to point source. Most of them trying to capture kind of a big, as Al Gore mentioned it recently in one of his TED sessions, he called this big vacuum cleaner, trying to take the carbon out of the atmosphere.
So you're talking about a circular solution here, when you create value out of carbon, right?
It took us some time to figure it out and build a process that managing to capture the carbon and actually engage it with additional industrial waste. And through our process, we're creating two end products. From the waste, we're managing to abstract and bring back sulfuric acid on one hand, and on the other hand, create calcium carbonate, a limestone, that it's a permanent lock of CO2 and can go to construction, can go to cement or concrete.
So I understand that you can work with different materials, and it will depend on the industry that you are working with. Both the intakes and the final products that you will release will be different, correct?
The final products will be different on the purity. The process will be the same, But calcium carbonate, you have a very basic spec for cement, and you have higher spec for plastic or paper. So the idea is that we're looking to support those really what we call heavy, dirty industries. Okay, we're looking to support steel, and we're looking to support concrete, and we're looking to support fertilizers, of course, first, because it's very internal kind of circular approach. All the value chain in their yard, I'm taking their byproduct, I'm giving them back my products. I'm taking their pollution and bringing them back the products.